In this video, I'd like to talk about the random access file class. Random access file is kind of a hybrid between the data input stream and the data output stream in that it has the functionality and methods from both of those classes. If you only want to do input or output and not both, then it's better to use data input stream or data output stream because they're a little bit faster. But random access file is great when you need to both write to and read from a binary file. So this code here is very similar to the code given in section 19.7 of your textbook. What this does is we open up a random access file handle to a file called random, and here you can see we're opening it in read and write mode. So if I just had an R here, we would only be able to read from the file, and if I just had a W, we would only be able to write to the file. But both RW means we can do both of those things. Also note that in a lot of the examples that I use in the jar file that's included with this week's topic, I call the binary files .dat, which is short for .data. File extensions in Java, they don't mean anything. So just because I call something .txt or .dat or something like that doesn't make it a text file or a binary file. What makes it text or binary is how you write to it, not what you call it. So here I've just called the file random with no file extension at all. What this code does here is we loop from 1 to 10 and we just write these integers to the file called random. So it's just writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what we're doing is we want to read out the fourth number out of that file. So with a random access file, you have something called a file pointer that controls where your location is in that file. So at first, when we first create the file pointer is sitting at the first byte of the file, so right at the beginning, which is byte 0, because programmers like to start things at 0. Then when we write out the number 1, that's an integer, and an integer in Java is 4 bytes long. So we write out the number 1 and the file pointer moves to right after the place we wrote to. So at this point the file pointer is at position 4 because it's written to byte 0, 1, 2, and 3. So we're right at position 4 or byte 4 of the file. Similarly, when we write the next number out, we write wherever the file pointer happens to be. So because the file pointer happens to be at position 4 or byte 4 of the file, that's where we write the number 2 and so on. So by the time that we get out of this loop, the file pointer is right at the end of the file, right after the number 10 that we wrote. What we want to do now, let's say that we want to read out the fourth number, the fourth integer in this file. So to do this, we need to move the file pointer to where that number is so that we can read it out. If we tried to read right now, right after this loop completed, we're at the end of the file, so we wouldn't see anything because we're at the end of the file. So we need to do a seek call, and seek is the method to move the file pointer around. And seek is always relative to the beginning of the file, not to where you are right now. So I'm going to seek here 12 bytes from the beginning of the file. So the question is, if we want to read out the fourth number, why aren't we seeking 4? Why are we seeking 12? And the reason why is because we need to skip over the first 3 numbers in the file. So that's where the 3 comes from. We're skipping over the first 3. But each of those numbers is an integer, and an integer is not 1 byte long, it's 4 bytes long. So that's why we need to multiply by 4 there. So we're seeking over 12 bytes because there's 3 numbers, each is 4 bytes long. And then once we've moved the file pointer to the correct position, we read in the integer, and then I just print it out and close the file. So if we run this, we see the number is 4, which makes sense because we just wrote them out in order, so the fourth number is 4. In the second video for this week, we're going to look at how to modify this program to work with doubles rather than integers, and maybe also characters rather than integers.